So, is the screen visible? Is the screen visible? Good
Yes,
morning,
sir.
Mohan. Yeah. Okay, fine. So, after process management, which is very important aspect of operating system, there are other managements also, other responsibilities that are carried out by operating system, like memory management, IO management. Of course, in the memory management and the secondary storage management is also there, and IO management. Of course, the main aspect of computer is executing the program, that is process. The process management we have discussed thoroughly. With that fundamentals, we can easily go with other managements like memory management, secondary storage management, IO management, etc. So now we see the memory management. Am I audible? Am I audible? Am I audible clearly?
Yes, sir.
Yes, is it? Am I audible to all of you?
Yes,
Yes
sir.
or no?
Yes, sir.
Thank you. Okay, so memory management, which is very simple. I tell you, I try to give you in a simple manner. Just listen carefully. This will help you to understand, right? So I try to explain in a simple way. Please listen carefully. Generally, we see any that is any space as some collection of locations, a collection of space. Okay, we divide the given entire location into collection. So that is the general way of looking at. Okay, so suppose this is the memory. Okay, so this is memory. When I say, as we already we discussed. So memory means always main memory. Okay, RAM. Okay, so this memory management exclusively of RAM, main memory management. Okay, so here whenever we say some space, okay, we visualize that space into some partitions, right? So here, see, suppose, of course, in order to distinguish each partition, we need to give some index for that, or we can say the address. So, for example, so here, okay, so likewise, we give the numbering. So the first location is 100, the second location is 101, 102, 103, and so on. Okay, so whenever generally what for we use what for the memory is used? Anyone? Anyone? Why the memory is used in the computer? Please, anyone? Which is stored in the RAM? What is
store the processes?
Yeah, to store the processes. Very good. To store the processes and data. And not only the user process, but also system process, like even operating system is stored, right? So thereby generally the memory is divided, some portion of the memory is divided for the operating system, and the remaining area is user area, right? So, and of course, where the OS is stored, from which address to next address, and also each user process where it is stored, everything. Because so here we can say each partition can be for example, say for 4 KB. Okay, so like this. So every partition likewise for example, this is the scenario. Okay, so each partition, okay, per se, assume that it is 4 KB size, right? So for example, I have a process of, suppose I have a process of 8 KB. I have a process of 8 KB. So, for example, so here the lower portion is dedicated for OS, and the upper portion is for user area, for example. Okay, so this is the initial snapshot of a computer when it is switched on. Now I have a program of 8 KB where it is stored. OS stores that program into which locations? Tell me where it is stored. So this is the initial snapshot. So obviously the 8 KB process is stored in the 8 KB process is stored in the 100 location as well as 100 location as well as, tell me, 100 location as well as
101, sir.
101. Very good. So because ours is 8 KB. Okay. So that is so this suppose this is the process P1. Okay. This is P1. So it means that here the P1 is stored here as well as here. Okay. And for example, now I have, for example, my process is another process I am taking, which is of 2 KB, 2 KB, 2 KB, process 2, where it is stored. Already 100 and 101 are occupied by P1. Now where this process P2 is stored? Which location? Tell me. Which location?
102, sir.
Yeah, 102. Yeah. So in this 102, the P2 is stored. Okay, but it is only of size 2 KB. Okay. So, and suppose I have similarly, I have one more 5 KB process. Okay. So a 5 KB process. Please listen carefully, only of 15 minutes. This is simple explanation. So now I have a 5 KB of process 3. Five KB of process 3. Fine. Okay. All are equal size 4 KB. Okay. So now tell me the 5 KB P3, where it is stored, in which locations? Already these first 3 locations, 100, 101, 102 are over. Now the P3 is stored at, so this 103 as well as, so it can accommodate only 4 KB of P3 at here. Okay. And where the 1 KB of P3 is stored? Here. Okay. So now if you look at this scenario, it is very simple to accommodate the process into the respective free locations. Okay. Then, but do you identify any problem here? Anyone?
Memory allocation
Memory allocation?
differs, sir. 102 to back to
Yeah, 102. So P2 is only P2 size is 2 KB. But what about so the remaining 2 KB is wasted in the 102 location, right? So because they are fixed size partitions. Okay. So similarly, for P3, how much is wasted? For P3, also memory is very good. Memory is wasted for P3. So how much due to P3, how much is wasted? Due to P2, 2 KB is wasted. Due to P3, how much is 3 KB? Very good. So this is called as wastage of memory space. So, so can you suggest any solution for this? Why this is happening? Because all the partitions are of fixed size. Okay, all the partitions are of fixed size. This is happening. Okay, so Have you overcome this? Have you overcome this? So what is the opposite of fixed? What is the opposite of fixed? What is the opposite of constant?
Dynamic.
Dynamic or variable. Okay, variable. So now the other kind of memory allocation is that is called as variable size. Please take take the screenshot of this. This example is of fixed size partitions. Fixed size. Fixed size. Please listen carefully. Very simple. Fixed size. So due to this fixed size partitions, we are getting some wastage of memory. Now we can go to the variable size partitions. Okay. So variable size. Okay. So here, so now you look at this right table. So now the main memory, if you look at this main memory, okay, memory, how it is partitioned, fixed size or variable size? The right side table, the right side memory. Tell me how it is partitioned.
Variable, sir.
Very good. Variable size partition. So this is variable size partition. Variable size partition. So this is variable size partition. So to overcome the drawback of fixed size partition, now we are going to the variable size partition. So for example, here, so the 4 KB, suppose the P1 is stored here, 8 KB, P1, and of course P1. Okay, so 8 KB. So there are the partition size is not fixed. Okay, so this is 4 KB, 4 KB, and this is also 4 KB. So this is not like this. Entire P1 is 8 KB, not like fixed size. Please take it. So P1 is 8 KB. Okay. Suppose and P2 how much? P2 is how much? P2 is how much?
2 KB, sir.
2 KB. Yeah, good. 2 KB. So 2 KB. So it is not the size of partitions are not fixed. Okay. So this is just 2 KB. This is just 2 KB. Okay. So though here I cannot show it as a different size. Otherwise, I do one thing. Otherwise. Okay, so the P2 is to 2 KB. Okay, and so the P3 is 5 KB. P3 is 5 KB. 5 KB. So now is the problem solved here? So how much size is required? That much size is allocated. So here, for example, okay, after 2 KB, we are remain with the 2 KB is remained here. 2 KB is remained here. Okay, so this is also some occupied by some process. Okay, this is also occupied by process. Occupied, and this is also occupied. Okay. And this is of, for example, 4 KB is free, and this is, for example, 6 KB is free. See, for example, a new process came. Okay, which is P4. So which requires 3 KB, where it is placed. So this is, for example, 205. Listen carefully. 206, and this is 207. Okay, so for example, a new process P4 came, which is of size 3 KB. At which address it can be placed? Anyone?
So 206, sir.
206, because this is called as whenever a new process comes, okay, there is an algorithm called as best that is best fit and worst fit, first fit, best fit, and worst fit. First fit, best fit, worst fit. Worst fit. Okay, it sees, okay, the partition, okay, which is best suited without okay, so it takes that that one. Okay, so for this P3 206 is taken. Okay, and for example, so now P3 is placed, P4 is placed here, P4 is placed here. Okay, and here for example, so I have a process of, suppose I have a process of now, I have a process of, I have a process of P5 of size, okay, for example, 8 KB. 8 KB. So where can I place this P5? At 202, okay, how much is left? 2 KB. And where another space is left, for example, this is not
207, sir.
207, 6 KB. So can I place P5 as some part of the 202 and the 207? Can I?
Yes, sir.
Yes, but this scheme is contiguous memory allocation. Please take down. So this scheme, what we have discussed so far, is called as contiguous memory allocation. Contiguous memory, contiguous or continuous memory allocation. So in the continuous memory allocation, what it says, the entire process should be available in the continuous partitions, continuous locations. Is it understood, everyone? So if this is the case, can I place the P5? Can I place the P5? So where is this P5? Yeah. So in this scenario, can I place 5K, 6, 8 KB? So if it is so, is it continuously placed? The 2 KB is at 202 and 6 KB is 202. Can I place or can't I place? I cannot place. Tell me. In the contiguous memory allocation, okay, can I place it or not? Continuous memory allocation means the entire process should be at same continuous locations. Anyone? P5 can be placed or not? P5 can be placed or not? P5 can be placed or not? Please tell me. కంటిగ్యూస్ గా ఉండాలి, కానీ ఇక్కడ 2 KB ఒక దగ్గర ఉంది, 6 KB ఇంకో దగ్గర ఉంది. మనం ప్లేస్ చేయొచ్చా చేయలేమా? ప్లీజ్ రెస్పాండ్. Please respond.
No, sir.
No. So here in the variable size also we are facing one problem. Okay, this scheme so far we have discussed is contiguous memory allocation. Okay, contiguous memory allocation. Contiguous memory allocation. Contiguous memory allocation, we are having fixed size as well as in the contiguous memory allocation, we are having fixed size as well as variable size partition. Fixed size is the first table, and variable size. Variable. What is the drawback of fixed size? What we are facing in the fixed size? Some space is left inside the, because they are fixed size, some space is wasted inside the partition. So that is called as internal fragmentation. Wastage of memory in the fixed size partition scheme within the partition is called as internal waste, internal fragmentation. Okay. So whereas in the variable size, though the memory is available, but we cannot accommodate due to this fixed contiguous memory scheme. So what this wastage can be called as? So this is in the fixed size, we are getting the waste inside the partition. Whereas in the variable size, we are getting the partition, we are getting the waste outside the, okay, which are not contiguous. So what is the opposite of internal? What is the opposite of internal? What is the opposite of internal?
External.
External fragmentation. Good. External fragmentation. So summary, please note down. Okay, the first scheme, what we have seen is contiguous memory allocation. Here we are having two cases, fixed size. Okay, we are having two cases, fixed size, fixed size as well as variable size. Okay, and in the fixed size, what is the drawback? We are getting internal fragmentation. We are getting internal fragmentation, internal. Whereas in the variable size, what is the fragmentation we are getting? External. Okay. So that is the case. Okay. So what is the solution for this? So how you can accommodate this P5 8 KB if we get a relaxation or flexibility? Can you suggest anyone? Which is very, very important. I repeat my question. So in the contiguous memory allocation, we are having fixed size and variable size. In the fixed size, we are having the drawback of internal waste. In the variable size, though the required space is available, as it is not contiguous, we are getting the also wasted. We cannot able to accommodate. Okay. So to overcome this, what you can suggest? Anyone?
Fragmentation.
That is, fragmentation is wastage. The word fragmentation is used to used for wastage of the space. Okay. So the contiguous memory allocation suffers from both internal fragmentation as well as external fragmentation. Why? Why we are unable to? Why we are unable to place this P5 8 KB even the space is available due to the restriction of the entire process should be in, I repeat, continuous. So what can be the solution or what can be the remedy for this? Instead of restricting, every process should be in continuous location. We can overcome it. We can relax it with, instead of contiguous. What is the correction we can take? The process cannot be placed in the contiguous memory locations. Rather, it can be placed in. What is the opposite of contiguous?
Discontinuous.
Discontinuous or non-contiguous memory location.
Uncontrollable.
Non-contiguous memory location. Okay. Is it clear, all of you? Contiguous.
Yes, sir.
Why we are moving to the non-contiguous? Yeah. non-contiguous. Okay. So here, so what is the solution for this? What is the solution? Please tell me. So please tell me what is the solution for this? So instead of contiguous, we are going for a relaxation of, tell me. The process can be in the non-contiguous location. Is it? Yes or no? Yes or no?
Sir.
Please. Yes, non-contiguous memory location. Non-contiguous memory location. Non-contiguous memory locations. Non-contiguous. So now, okay, the here. Okay, so non-contiguous memory location. Okay, so now, so here, if we take, so if you take the same case now, okay, so if we take the P5, now P5 of 8 KB, 8 KB. So where can I place now? So here P5 8 KB, where can I place now? So where can I place now?
203 and 207.
Okay. Okay. So I can place. So I can place the P5 in 202 2 KB and 276 KB. So this is non-contiguous memory allocation. Now, okay, it is very good. It is very fine that the memory is used effectively, but do we require any extra overhead due to this? Anyone? Suppose I want to access P5. How can I know the address? How can I know the address? So suppose if it is continuous, if I know the starting address, I can get the complete process. But the P5, some part of the P5 is at 202 and the remaining part is at where it is? Where it is?
207, sir.
207. So here we require extra overhead. We require some indexing. Okay. So in the index, yeah. So we require some indexing that. So like we take one more table like this. Okay. So that is the main memory. So for this, we have to take an index table. Okay. So the index P5. So P5, where it is available, some part is at 202 and another part is at 207. Okay. So this is the extra overhead. Remember, whenever we want to get some extra convenience or effectiveness, okay, we need to we need to face some complexity. That is a very natural thing. I used to tell this always. Okay, so this is called as, okay, instead of like this, in the non-contiguous memory location, the memory is divided into pages, equal size pages, and the relaxation is it can be placed, the process can be placed at different number of pages. So this is called as paging. This is called as paging. This is called as paging. Is it clear? The basis point of paging. Paging is what kind of memory allocation? Contiguous or non-contiguous? Like in textbook pages, okay, the textbook, suppose there is 100 pages. Okay, how to get some particular topic, how to go to some particular topic by looking at the textbook. Suppose I want to go for memory management. in the textbook. Because it is variable size, the memory management can occupy 50 pages. The another kind can be like that. So likewise, something is at one place. So how the textbook is accessed?
Index.
Yeah, very good. That index is called as here page table. Okay. So this paging is called as non-contiguous memory location. Okay. Is it understood to everyone?
Yes, sir.
Yeah. So now I share the PPT, then you can better understand. Okay. So with only 10 minutes, I stop the session. Only 10 minutes. So this is the topic of memory management, contiguous memory allocation, then paging. Okay. So here, so this is is the screen visible? I go in a quick manner. Is it visible? Yes or no? Is the PPT visible?
Yes, sir.
Yeah. So this is the main memory, operating system process. So how the process can be the base register value, base address plus limit, base plus limit. Okay, likewise. Okay. So here, how the addresses are protected such that no duplicate process can be stored at one place. So first of all, CPU generate address. Okay, is it so it cannot be placed in the OS location. It checks in the base register address and base plus what is the limit of that, accordingly that is placed. Okay, so generally the logical address and physical address. So whenever we want to execute a program, okay, that program is to be placed in the main memory. Okay, immediately the CPU generates the address for each instruction. It is called as logical address. Okay, so whereas it is logical address, whereas actual address of the memory unit is called as physical address. So this logical address space is the set of all logical addresses generated by a program. Physical address space is the set of all actual addresses, the set of all physical addresses generated by a program. Okay, so the actual locations. Okay, that is the case. This is logical address space and physical address space. So this is CPU, logical address, memory management unit. Okay, so this is a program, generates the actual physical. So understand, CPU gives some address to the each instruction. It is taken by the memory management unit and generates the actual location, pre-location of the physical unit. Okay. So that is main memory management unit. Okay. So this is the way CPU generates a logical address 346. So the relocation address is so from 14,000. Okay, the memory is suppose allocated to user area. So 346 plus 14,000, that is the address of that process. Got it? Are you following? I'm going in a quick manner as they are simple things. Are you following or not? Are you following?
Yes, sir.
Yeah, please. They are simple things. Yeah, I am. So contiguous allocation. Just now we have seen main memory must support both OS and user process. Main memory usually into two partitions for OS and other one is user area. So contiguous allocation. Okay. So the CPU, the program is placed like this. CPU generates logical address, limit register plus physical address. Okay, by adding the relocation address, okay, we get the actual okay physical address. We have seen what is the drawback of fixed size partition, internal fragmentation. For that, we are going for variable partition. A block of available memory, holes of various sizes are scattered throughout a memory, but they are not contiguous. Okay, so this is the case we have seen. I have explained you. Okay, so how the storage can be placed in the variable size partition, I explained. First fit, allocate the first hole that is big enough. Best fit, allocate the smallest hole that is big enough. Worst fit, allocate the largest hole. So for example, here, this is the case. Suppose we want to accommodate a process. Okay. So we have to see, okay, for what is the, suppose I have a 2 kb, I can place to over here. That is the, so in the first fit. So in the best fit, I have to see the least partition that can be fit for. Worst fit, I have to choose big. So our OS maintains information about what are the already allocated partitions and what are the free partitions. Free partitions are called as holes. They are scattered throughout the. Okay, so that is the first fit best. So external fragmentation, total memory space exists to satisfy a request, but it is not contiguous. We have seen it. Internal fragmentation, allocated memory may be slightly larger than requested memory. The size difference. So suppose 4 KB partition is there, but we have assigned only 3 KB. That 1 KB is left. That is generally internal fragmentation is formed in the fixed size partitions. So fragmentation. How to reduce fragmentation? So to reduce the fragmentation, we have to combine the locations, okay, free locations. So that is the way of, okay, reducing the fragmentation. So to overcome the contiguous memory allocation, which is expecting the program should be available in the contiguous memory, we are suffering from memory waste. To overcome this, paging. In the paging, physical address space of a process can be non-contiguous, but it can also be divided into fixed size blocks of same size pages, but the program can be available at different location. So this is the indexing, in which page number, how much page offset. So how much, okay, how many pages it occupied. Okay. So paging hardware. Okay. So the page table. So likewise, the pages. Okay. The logical partitioning is called as pages, but actual physical memory, they are called as frames. Okay. And the CPU generates logical address and the frame. Okay. The D is offset. Okay. Where it is, how much space, how many pages it is requiring. The F is frame number. Okay. The page, so CPU generates logical address which contains page number plus offset. So this is page number plus offset. So for example, page number is 4 and it is of size of KB. That is the offset 5 KB. So here the page number, okay. Suppose the page, so page number, if you look at this, this will be. So this is logical memory is divided in the paging. Logical memory is divided into pages. Logical memory means which is not existing, only for CPU convenience. We assume that memory is divided into pages. Okay. So the actual physical memory is divided into frames. 0th frame, frame 1, frame 2, frame 3, like that. Okay. So here, if you look at this, okay, if you look at this, the page 0 is available in placed. The page 0 is placed in the frame number 1. So don't confuse here. The logical memory is divided into pages. The physical memory is divided into frames. Okay. So here, so this is frame. So this is the physical memory. Don't confuse. So this is logical memory, which the OS assumes. Okay. So the page table contains, okay, the page number. Okay. This is page number. Okay. So this is, okay, frame number. Please tell me page 0. What is the frame number of page 0? By looking at the page table, tell me. Page 0, in which frame it is available? Please tell me.
Frame 1.
Frame 1. So these are frame numbers. Please remember the logical memory is divided into pages in paging. Okay, so here, suppose a program, as we have discussed, the 8 KB of P5, okay, can be placed in the frame 1, frame 3, frame 4. So it can be obtained from page table. Okay, so non-contiguously. So the memory can be, so wherever it is available, the free frames, the program can be allocated, and that can be accessed from the page table. So if you are asked to explain paging, you have to explain, okay, like this. If you're asked to explain the paging, physical address space of process can non-contiguous. Paging is a non-contiguous allocation. Okay. So suppose the logical memory is divided into pages. To run program of a size n pages, how many free frames we require? n pages ki any free frames undalandi main memory lo. Suppose I have a program which requires some 3 pages. 3 pages. So how many free frames are required in order to place these 3 pages? Suppose this is P6. How many free frames are required? Page size, frame size equal andi. Suppose page is 4 KB, frame is also 4 KB. So 3-page program requires how many frames? Anyone? To run a program of size n pages, need to find any frames. ఇక్కడ 4 పేజీలు ఉన్నాయండి లాజికల్ మెమరీలో. ఈ ప్రోగ్రామ్ 4 పేజెస్. ఈ పేజ్ 0, పేజ్ 1, పేజ్ 2, పేజ్ 3 కి ఎన్ని ఫ్రేమ్స్ కావాల్సి వచ్చింది? సో దిస్ ఈజ్ మై 4. So this is my actual program, for example, which requires this much size, 4 pages size. Where they are available in contiguous or non-contiguous? Contiguous unnaya, non-contiguous unnaya na program yokka 4 pages main memory lo?
Non-contiguous.
Non-contiguous. So can they be accessed easily? How they accessed? From where it can be accessed? What is the mechanism to access it? What is the mechanism to access it? Tell me. ఈ రెండింటికి రిలేషన్షిప్ ఏది ఎస్టాబ్లిష్ చేస్తుంది? ఇది పేజ్ లాజికల్ మెమరీ అండి. దిస్ ఈజ్ లాజికల్ మెమరీ. సో దిస్ ఈజ్ ఫిజికల్ మెమరీ. లాజికల్ మెమరీ మీన్స్ ఓన్లీ ఫర్ ద CPU assumed memory. So what is there in between to establish relationship between logical memory and the actual memory? What is in between? Please tell me. Page table. The page table establish the relationship between the logical pages and where they should be available in the main memory. This is very, very important. So మీరు పేజింగ్ అడగగానే అవి ఎక్స్ప్లెయిన్ చేయాలి. ఇది నెక్స్ట్ ఇది కూడా కొంచెం డీటెయిల్డ్ ఎక్స్ప్లెనేషన్. ఇది అర్థమైతే ఇది. Is it clear, the paging? So is it? Yeah, fine. So I share this PPT by editing unwanted these things. Okay. So this is a detailed explanation. Okay, how the pages are stored. So 0th page, it is available in the frame number 5. 5, yeah. So page table. So 0th page, okay. 5. Two, three, 0, 1, 2, 3, 4. ఇదండి 5. అడ్రస్లు కాకుండా ఈ 20th ఎన్ని ఫ్రేమ్స్? 0th ఫ్రేమ్, ఫస్ట్ ఫ్రేమ్, సెకండ్ ఫ్రేమ్, థర్డ్ ఫ్రేమ్, ఫోర్త్ ఫ్రేమ్ అండ్ 5th ఫ్రేమ్. ఓకే, ఆర్ యూ ఫాలోయింగ్? సో 0th పేజ్, ఓకే, zeroth page, okay, zeroth address A, where it is available in the fifth frame. 1, okay, the B, okay. So this page, so second page. So this is zeroth page. So this is page 0. So this is page 1. This is page 2. Please listen carefully. This is frame 0. So this is frame 1, frame 2, frame 3, frame 4. This is frame 5. Now see the page table. 0th page. What is the frame number? Chappandi. 0th page. What is the frame number? Tell me. 0th page frame number anta undi page table lo. Please tell me. 0th page frame number anta?
5.
5. Idi 5. So 0th page contents ABCD. ఈ ABCD ఇక్కడ ఉన్నాయి. ఇవి అడ్రస్ లో 20 ఇవన్నీ ఫ్రేమ్ నెంబర్ డోంట్ కన్ఫ్యూజ్. ఓకే, అలాగే పేజ్ 1, సో పేజ్ 1 పేజ్ టేబుల్ చూడండి, దాని ఫ్రేమ్ ఎక్కడుంది? పేజ్ 1 యొక్క ఫ్రేమ్ నెంబర్ ఎంత? ఎక్కడండి? పేజ్ 1 యొక్క ఫ్రేమ్ నెంబర్ ఎంత? 6. అంటే దిస్ వన్ ఈస్ 6. ఓకే, దిస్ వన్ ఈస్ 6. సో దిస్ వన్ ఈస్ 6 ఫ్రేమ్. ఓకే, సో ఈ పేజ్ 1 యొక్క కంటెంట్స్ ఏంటి? ఈఎఫ్జిహెచ్ ఇక్కడ ఉన్నాయి. అర్థమైందా? సో దిస్ ఈస్ ద డీటెయిల్డ్ ఎక్స్ప్లెనేషన్, డోంట్ కన్ఫ్యూజ్. ఈజ్ ఇట్ క్లియర్? ఈజ్ ఇట్ ఫైన్? యా, దిస్ ఈస్ రిగార్డింగ్ పేజింగ్. ఓకే, సో with this I stop the class. Thank you all for attending. So nearly 50 students have attended. If possible, I share this recording in the group. So those who were absent, okay, they can go through that recording. Shall I share the recording? Shall I?
Yes, sir.
Yeah, I share the recording. Okay, so those who are who were absent, okay, so they can do check this. Okay, then we have one more concept in the main memory management. Okay, that is virtual memory management. Okay, so that we will discuss in the next class. Okay, thank you. You can leave the session. Anyhow, I share the recording in the group. Thank you. Thank you for attending.